November 13, paper 21, number 9, figure 9.1 shows a series circuit. The resistance in the ammeter and the battery may be ignored. Here is the circuit. What's the component? X? Take one box. As you know, this component is a resistor, not a fuse, not a bell, nothing else. This is only a resistor. Then moving on to the next part, state the value of the EMF of the battery. EMF means the value of the battery. Here it's a 6 volt. This is the input voltage to the circuit. So the EMF of the battery is 6 volt. And then moving on, the potential difference across the component X. Since there is no other resistor inside the circuit, so all the voltage or the EMF here will be used by this resistor. So the potential difference across the resistor will be as well as 6 volt. So here a 6 volt as well. The current in the circuit. The current in the circuit is only a 250 milli. So here the current will be a 250 milliampere. You should state this, that this is a 250 milliampere. Or you could say that it's a 0.25 ampere. Both are right. Use the values from figure 9.1 to calculate the resistance of the component X. Give the unit. So in order to calculate the resistance, we will talk about this using Ohm's law. Ohm's law, here is the triangle, here is the V. It should be equal to I times R. So in order to get the R, we say that R is equal to V over I. Then at last, the voltage is 6. The current is 250 milliampere, which is a 10th power of -3. So the total resistance, please make sure on your calculator you state this. So at last, the final resistance here should be 224 ohms. Okay, that's for this part. Moving on to the next part. A resistor R is connected in parallel with component X. So here we should make a drawing to the component, the resistor R. Let's move up. Here he said that there is another resistance which is called resistance R. We don't know its resistance, and it's now connected in parallel to the resistance X. And he's asking what will happen to the total resistance of the circuit. What happened to the total resistance of the circuit? We know before that if we are having, for example, here two resistors, one resistor, 2 ohm, and another resistor, 2 ohms as well. So here it's a series circuit. So the total resistance, if we are going to draw the circuit again with a total resistance, it should be a 4 ohms resistance. This is for a series circuit, a normal series circuit. But what if we are having the 2 ohm connected in parallel? So here a 2 ohm resistor, and here another 2 ohm resistor. 2 ohm in parallel, 2 ohm, and here a 2 ohm connected in parallel. So in order to get the total resistance of this circuit, we should make our total is equal to product over sum, which means 2 times 2 over 2 plus 2. So the total resistance now will be 4 over 4. So the total resistance will be 1 ohm. So a general note stating that whenever I'm having a 2 parallel resistor the total resistance of those two parallel resistors is always less than the least one. Less than the least one. So if I'm having here two resistors that are connected in parallel, their total resistance is less than the least one. So for sure, the total resistance now will decrease. So as you can see here, the total resistance of the circuit will for sure decrease. The reading on the ammeter. So whenever we said that using Ohm's law, we said before that R is equal to V over I. When the R decreases, what will happen to the current? The current will increase. So here, we will say that the current or the reading on the ammeter will increase. What about the current in component X? This is a tricky question. The current in component X, here we said that we will connect the resistance, another resistance R, to this circuit. So what will happen? The current coming out of here, that will decrease, that will not be at 250, will come and then it will be divided part to the X and part to the Y. Okay, so here it will have an I1 and I2. The information that for the X is still unchanged, which means that the resistance of the X unchanged, because actually we didn't make any changes to the resistor X. This is one thing. The second thing is the voltage across the resistor X as well. It will stay a 6 volt. So the resistor and the current and the voltage doesn't change, do not change. So now I could say that since the resistance will not change and the voltage will not change as well, is not changed. So it means that the current also will stay the same. So here, for this part, the current that already entered this or was inside this circuit was equal to, current was equal to V over R. Okay, V was a 6 volt and the R was Rx. No change in that. When we added another resistor in parallel, resistor R, the total current coming out of here will not be at 150, it will change. As we said before, the current will increase. So when the current will increase, it will now be divided. One branch here will have I1 and the other branch will have I2. Based on what? Based on the equation. Let's see this branch, first branch. What are the information that we have? We have information that R resistance is Rx, stay the same like the previous one. And the voltage across the resistor X is still 6 volt. So the current that will be taken from the total current will be as well, it will be the same current, which is a 250 milliampere. So the current will not be changed. So there will be no change for the current. So for the last question we have here, the current here will be unchanged. Thank you.